Hi friends, good morning. Today we are going to discuss another section of differential equation, that is Bessel differential equation, right? Bessel differential equation. So this Bessel function actually the solution of Bessel differential equation, right? So what is Bessel differential equation? A differential equation of this format. That means x square d square y by dx square plus x dy by dx plus x square minus alpha square into y is equal to 0. A differential equation of this format, right? Of this format is called a Bessel differential equation. Alright? Alright. Now how we solve this Bessel differential equation? See, first we consider a series solution method. Now consider a series solution as sigma n is equal to 0 to infinity a n x raised to n. Alright. Now from this you find dy by dx, d square y by dx square. Say dy by dx you find, then d square y by dx square you find. Right. These values you substitute here. Right. dy by dx here, d square y by dx square here, and y value also substitute here. Then by substitution we get a generalized equation to solve coefficients a0, a1, a2, etc. By substituting that we can solve the final solution for y, right? So that is the method we have studied in series solution method. For the time being, this substitution and finding solution we are not considering. We need the final solution, right? So let us see, the final solution of this differential equation is j alpha of x. This is the final solution of this differential equation. Say j alpha of x is equal to sigma r is equal to 0 to infinity minus 1 raised to r into x by 2 raised to 2r plus alpha divided by r factorial plus alpha plus r factorial, right? So this is j alpha of x, right? So j0 of x, from this we can find what is j0 of x. j0 of x is equal to this first Bessel function j0, j1, right, j2, this and all you need to by heart, right? Oh, let us solve what is j0 of x. j0 of x is sigma r is equal to 0 to infinity, put alpha is equal to 0, right? Then 1 by here r factorial, in here r factorial, and here x by 2 all raised to 2r. Now put r is equal to 0 to infinity. Then here you have minus 1 raised to 0, that is 1 into 0 factorial, again 1 into x by 2 raised to 0, right? Now what next is r is 0. Now put r is equal to 1. Then what you get minus 1, put r raised to 1, then minus here 1 minus 1, right? That minus come from 1 factorial, right? That is 1. Then x by 2 the whole square, right? Now so here x by 2 the whole square, right? So and for r is equal to 1, right? Put r is equal to 0, then r is equal to 1, now put r is equal to 2, then this is a plus term, right? Then here 2 factorial into 2 factorial, that is 1 by 4 into, right, into x by 2 all raised to 4. So it will go like this, right? So what is j0 of x? 1 minus x by 2 the whole square plus 1 by 4 x by 2 all raised to 4 minus etc. Right? So this is j0 of x. Am I right? This is j0 of x. Alright. So similarly we can find put here instead of alpha you substitute 1, then here 1 plus r whole factorial, right? Then 2r plus 1, and then putting sigma r is equal to 0 to infinity, you will get a j1 of x, right? By solving this method, see, so if it is j minus alpha x you required means j alpha of x we seen j minus alpha of x, here instead of alpha you put minus alpha here also, right? Alright. Now see, also remember that j minus alpha of x, j minus of alpha of x is equal to minus 1 raised to alpha into j alpha of x. That is a result. That result also we require to do problems. So j minus alpha of x is equal to minus 1 raised to alpha into j alpha of x. Now see, this is our we solved, right? J0 of x we solved just before, right? That is 1 minus x by 2 the whole square plus 1 by 4 x by 2 whole raised to 4. Now minus 1 by 36 into x by 2. Similarly, in the same equation, what is the solution? We studied j alpha of x, that is equal to, right, sigma r is equal to 0 to infinity minus 1 raised to r divided by 1 by r factorial into, right, that is alpha plus r the whole factorial into x by 2 whole raised to 2 r plus alpha. This only we studied. Now by substituting this 0 j0, instead alpha replace with 0 and r is equal to 0 to infinity give, this is j0 of x. This already we seen, we derived, right? Similarly, you can find j1 of x also. See, j1 of x also you can find it. So for j1 of x, what I have to write? J1 of x equal to, then alpha you replace with 1, right? Then minus 1 raised to r, right? Here divided by r factorial into alpha is 1, then 1 plus r factorial into here x by 2 whole raised to 2r plus 1, right? Right. But here sigma r is equal to 0 to infinity. Now you put r is equal to 0 first, then r is equal to 0 means this term 1, this term 1, then 1 plus 0 factorial 1, then x by 2 whole raised to 1, then first term is x by 2, right? First term is x by 2. Now you put r is equal to, first 0 you put, next value 1, r is equal to 1 you put, then next term minus 1 raised to 1 is negative, so minus 1, and here 1 factorial is 1 factorial, here 1 2 factorial come, right, x by 2 whole raised to 2 plus 1, that is 2 plus 1 is, that is x by 2 whole cube, right. So r is equal to 0 to infinity you give means x by 2 minus 1 by 2 x by 2 whole cube plus 1 by 12 x by 2 whole raised to 5 plus etc. Right. So this what is Bessel differential equation? Very differential equation format we need and corresponding solution, this solution general expression, this we have to study, and then j0 of x, j1 of x, j2 of x. These values we commonly using for doing problems, right? So j0 of x by substituting in this solution, finding this j0 x value, j1 of x value, j2 of x value is very difficult, right? Why? Because in a previous GATE examination, not GATE examination, NET examination, directly they asked this j1 of x value. They asked j1 of 0, right? Then answer is 0 because every term having this x value, then j1 of 0 is 0. But whenever you know this expression, right, if j0 of 0 they ask means answer is 1. But j1 of x 0, j1 of 0 they asking means answer is 0 because every term having this x value, right. So this kind of problem to do very easily, you have to by heart j0 of x, j1 of x, j2 of x values, right? Alright. Now generating function. Generating function means, see, look here. To find j0 of x, jn of x, suppose you consider this function you consider. In its expansion, this is an exponential function, right? So, e raised to 1 by 2x into t minus 1 by t. After expanding this, if you take a coefficient of t raised to n, that is equal to jn of x. You can verify that. For example, this I can write, this function say I can write as e raised to 1 by 2 xt, 1 by 2 xt into e raised to x by 2t, right, minus x by 2t. I split this into two terms. Now, how I can expand this? This is xt by 2. Then by using exponential series, this is 1 plus xt by 2 the whole square plus 1 by 2 factorial into xt by 2 the whole cube, right, sorry, this is xt by 2, understood? 1 by 1 factorial into xt by 2, this is 1 by 2 factorial into xt by 2 the whole square. Next is 1 by 3 factorial into xt by 2 the whole cube plus etc., right, into this term expansion. This is again 1 minus 1 by 1 factorial into x by 2t, right, plus, right, e raised to minus x expansion, alternative terms are negative, right, then 1 minus 1 by 1 factorial into, then 1 by 2 factorial into x by 2t the whole square. Next is 1 by minus 1 by 3 factorial into x by 2t the whole cube plus etc., right. Now, this expansion, suppose you need j0 of x value, then what? Coefficient of t0 you take from this. What is coefficient of t0? This into this. 1 into 1 what? 1. Then coefficient of t raised to 0 first term is 1, right. Now, by multiplying this with this 1, then coefficient of t raised to 0 not there, but by multiplying this and this, here numerator 1t, denominator 1t, right, both cancel, and what is coefficient of here, you get this plus into minus minus, coefficient of t raised to 0 is x by 2 the whole square, right. Now, you multiply this with, right, this, then what, t here t square, denominator here 1 by t square, both multiply, t square cancel, there also 1 t raised to 0 coefficient, right. Then t raised to 0 coefficient means the term which not involved with t, right, alright. Then this into this what, 1 by 2 factorial into 1 by 2 factorial, that is 1 by 4 factorial into here x by 2 into x by 2 square, x by 2 square into x by 2 square, that is x by 2 whole raised to 4, alright. This only we previously studied as j0 of x. Then coefficient of t raised to 0, that is equal to j0 of x. Now, similarly, if you find a coefficient of t raised to 1, that is going to be j1 of x, right. j1 of x you can find from here itself. Look here, j1 of x, what is coefficient of t? This multiply with this, then coefficient of t you will get, because only 1t, that is x by 2, right, minus. Now, this multiply with this t, we need coefficient of t raised to 1. Then this multiply with this, then you get 1 t square here, denominator 1t, then coefficient of t raised to 1 you get, right. So, that is coefficient of t here x by 2 whole square, here x by 2, then x by 2 whole cube, am I right? Here 1 by 2 factorial, then 1 by 2 into x by 2 whole cube, plus next is this term multiply with this, then 3 factorial, that is 6, 6 into 2, that is 12, 1 by 12 into, right, this 3 into 2, x by 2 square into x by 2 whole cube, that is, right, x by 2 whole raised to 5 minus etc. This is j1 of x. j1 of x is the coefficient of t raised to 1, right. Similarly, j2 of x you can find, right. So, here the expansion of this exponential term, then you take the coefficient of t raised to n, you get jn of x. If you need j0 of x means coefficient of t raised to 0. If you need j1 of x means coefficient of t raised to 1, right? So like that, see, this already we seen, this is only j0 of x, this here is only j1 of x, we already derived, right? Alright. So using that, now this two result is very important, right? j1 by 2 of x, right, j1 by 2 of x is equal to j1 by 2 of x is equal to root 2 by pi x into sin x, right. J minus 1 by 2 of x is equal to root 2 by pi x into cos x, right. So these two results are very important. So what is j alpha x you studied? J alpha of x, what we studied, that is minus 1 sigma n is equal to 0 to infinity, sorry, r is equal to 0 to infinity, minus 1 raised to r, x by 2 all raised to, right, 2r plus alpha divided by r factorial into r plus alpha whole factorial. This we have studied, right? Alright. Now, suppose you need alpha j1 by 2 of x, right? Then what you have to put? Sigma r is equal to 0 to infinity minus 1 raised to r, right? Here alpha is 1 by 2, then x by 2 whole raised to 2r plus 1 by 2, am I right? Alright, divided by r factorial into r plus 1 by 2 whole factorial, right? Okay, this is the formula. Now this we expand and we need to get this, right? We have to prove this is the result, root 2 pi by x. For that I am applying two steps. See this, see I am writing this as j1 by 2. Here both multiplying, I need to remove this 1 by 2, right? Then x by 2 all raised to 1 by 2, right? Can I write this as a say j1 by 2 of x is equal to, okay, j1 by 2 of x is equal to, what I can write, that is equal to this r plus 1 by 2, see r plus 1 by 2 whole factorial is equal to, that is 2r plus 1 factorial divided by 2 raised to 2r plus 1 into root pi, right, into r factorial, right. This is the formula, right. So this is r plus 1 by 2 whole factorial expansion, 2r plus 1 factorial, right, 2r plus 1 factorial into 2r plus 1, 2 raised to 2r plus 1 root pi into r factorial, right. So we write that here, sigma r is equal to 0 to infinity, right. Here we have minus 1 raised to r, minus 1 raised to r. Here we have x by 2 all raised to 2r, right, x by 2 all raised to 2r plus 1, right, 2r plus 1, alright, 2r plus 1 by 2, alright, 2r plus 1 by 2 and r factorial into, right, r plus 1 by 2 factorial is, that is 2r plus 1 factorial into, right, 2 raised to 2r plus 1, right, into root pi r factorial, r factorial. This r factorial cancel. So, and see this root pi, I am sorry, this root pi here only, right, in this expression. So this root pi here only come, am I right? Alright. See, now this here we have one. So first of all I am writing, you multiply this with x by 2 all raised to 1 by 2. So root x by 2 I am simply multiplying on either side. Then root x by 2 j1 by 2 x is equal to sigma r is equal to 0 to infinity minus 1 raised to r. See, this root x by 2 is x by 2 all raised to 1 by 2. Here x by 2 all raised to 1 by 2 you multiply means this 1 by 2 plus 1 by 2 what, that is 1. Then here I can write as x by 2 all raised to 2r plus 1. 2r plus 1. Am I right? Right. And here we have, see here 2 raised to 2r plus 1 right, that is that come here, right, into 2 raised to 2r plus 1, 2 raised to 2r plus 1, alright. So this 2 raised to 2r plus 1 into 2r plus 1 whole factorial into root pi, right. So from this step I am going to we can write this root x by 2 j 1 by 2 x, am I right, j 1 by 2 x. See this 2 raised to 2r plus 1, here denominator 1 2 is there, then 2 raised to 2r plus 1, that we can cancel. Then what is pending? Minus 1 raised to r x raised to 2r plus 1 divided by root pi 2r plus 1 factorial, right. So here I forgot to put a sigma, this sigma r is equal to 0 to infinity, r is equal to 0 to infinity. Now you can give value, we can give a root x by 2 j 1 by 2 of x is equal to 1 by root pi, we can take out, put r is equal to 0, then this is 1, this is x cube, right. Now r is equal to 0 means x, right, x root pi taken out, 0 means 1 factorial. Next term is put r is equal to 1, then this will be negative and 1, this is x cube, right, and root pi we taken out, then 1 means 3 factorial. Next term is what? X raised to 5 by 5 factorial minus etc. Right. Now, say we can write it here. See, root x by 2 into root x by 2 into j 1 by 2f, j 1 by 2 of x. What I can write? That is equal to, this is sin x expansion, x minus x cube by 3 minus see x minus x cube by 3 factorial plus x raised to 5 by 5 factorial minus x raised to 7 by 7 factorial, that representing sin x series. So this is 1 by root pi into sin x. Now then j 1 by 2 of x is equal to, this come here, then you can write a root 2 by pi x into sin x, right. So that only this given. Similarly, you can derive j minus 1 by 2 of x is equal to root 2 by pi x into cos x, right. That only that result. See, so we can clear this, j minus 1 by 2 of x is equal to root 2 by pi x into cos x, alright. These two results also very important, am I right? Alright. Now, see, next is spherical Bessel function, right. It is what we have seen, general equation of Bessel differential equation is x square d square y by dx square plus x dy by dx, right, plus x square minus right alpha square equal to into y equal to 0, right. Now see, this alpha I am replacing with root n into n plus 1, am I right? This alpha I am replacing with root n into n plus 1. Then I can write this differential equation as like this, understood? So that particular differential equation is known as spherical Bessel function, or this differential equation of this format, right, that is known as spherical differential equation, and the solution of this differential equation we call it as spherical Bessel function, right. When we come to quantum mechanics, using this differential equation we are solving hydrogen atom, solution for hydrogen atom, right? That time you understand the importance of this equation, right? We are using in quantum mechanics to solve hydrogen atom, right? So this is this format, and its solution is, see, j n of x is equal to minus x raised to n 1 by x d by dx all raised to n sin x by x. Alright. Now see, what is j0 of x? From here, first spherical Bessel function, that is j0 of x. You can put a minus x raised to 0, and this raised to 0 is 1, and sin x by x, then answer is sin x by x, right? So first j0 of x is sin x by x, am I right? Alright. Now what is j1 of x? Next is j1 of x. What is j1 of x? j1 of x is equal to, see, put here minus x into all raised to 1, and then 1 by x into all raised to 1 is d by dx of sin x by x, right? Now x cancel, then minus of differential of this is what? First function into, right, denominator square, right, numerator into denominator into derivative of numerator, that is cos x, minus numerator into, then what I can write? This is sin x by x square minus this term positive I am writing first, then cos x by x, right? This is cancel, minus cos x. This is the j1 of x, right? Alright. Then j1 of x, j is first 0th Bessel function, Bessel spherical function, j0 of x value, that is sin x by x, and j1 of x sin x by x square minus cos x by x. Alright. So let us see. Here given list of j0 of x we have already seen. This is sin x by x, alright, sin x by x, and j1 of x, that is sin x by x square minus cos x by x. First two value Bessel function, right, that you have to by heart, and if possible j2 of x also you have to by heart, or you remember this formula before the general formula, right? j2 of x, j3 of x all are given, right? Now see, this sin x by x we already seen. What is sin x by x? In optics part we studied diffraction, intensity of diffraction, right, like this, right? So this curve, the graph, that is intensity is proportional to sin x by x term, right? So the sin x by x graph is like this, intensity diffraction, intensity distribution of diffraction, right? Intensity distribution of diffraction is like this only. That graph representing this spherical Bessel function, that is first 0th Bessel function, that is sin x by x. So that graph shape is this, alright. Now let us do some problems. See here, f of x is equal to sigma n is equal to 0 to infinity minus 1 raised to n factorial n plus 1 factorial x by 2 all raised to 2n plus 1. Actually what we have studied, sigma n is equal to 0 to infinity minus 1 raised to r, right, x by 2 all raised to 2r plus 1 divided by r factorial into r plus alpha factorial, right? This is our Jn of x. This is the solution of a differential equation. This is solution of which differential equation we have studied, right? This is the solution of the differential equation, that is equal to, see, x square, right, x square d square y by dx square, right, d square y by dx square minus, no, plus x dy by dx right, plus x square minus alpha square is equal to into y equal to 0. This only we have studied, right. So let us see this differential equation. We have seen okay. So this is the differential equation, Bessel differential equation we have seen with the solution is this. Now here alpha is replaced with 1, right. Here this alpha is replaced with 1. Here also this alpha is replaced with 1. Then alpha replaced with 1 means here x square minus this alpha changes, x square minus 1 square, that is x square minus 1 into y is equal to 0. Then only this is the, then the function it is this function f of x is the solution corresponding to which differential equation? That is this differential equation, but here alpha is equal to 1. Then x square minus 1 is equal to 0. Then x square d square f by dx square plus x df by dx plus x square minus 1 into f is equal to 0. Then option C is correct, right? Alright. So next question is, the graph of the function f of x shown below is best described by, right. So look here, see this graph is actually we have already discussed, this is a graph, see a part of which curve. So if either side you would draw like this only, right. This is a intensity distribution, okay, in a diffraction pattern, right. This graph is representing what is sin x by x. Sin x by x is what? That is Bessel function J0 of x, right. Bessel function J0 of x, right. Alright. So this is all about this section. First is the format of Bessel differential equation, then based on that is J0, J1, J2 values, and sometimes they ask J0 of 0 what, J0 of 1 what, J0 of so once J0, J1, J2, that is series solution that you know only you can substitute to find J0, right, J0 of J1 of 0, J2 of 0, that all we can find, right. And also the graphical nature of the spherical Bessel function, first spherical Bessel function, and also we have studied this generating function, right. From generating function also we can find out J0, J1, J2, etc. Alright, thank you.